For the last few years, if you've been following AI, you've probably heard one term over and over again: MCP, or Model Context Protocol. It's quickly becoming the standard way for AI models to interact with external tools. But on July 28, 2026, the MCP team released what is arguably the biggest redesign of the protocol since it was introduced. And this isn't just another version bump, it fundamentally changes how MCP works internally. It removes sessions, introduces a stateless architecture, simplifies scaling, and prepares MCP for a future where millions of AI agents are constantly interacting with tools. In this video, we'll break down exactly what changed, why these changes were necessary, and why developers are so excited about this release. Before we jump into the changes, let's quickly remind ourselves what MCP actually does. An LLM, by itself, only generates text. It doesn't know how to do things like access your file stem, search your database, read emails, or interact with APIs. That's where MCP comes in. Think of MCP as a universal protocol that allows any AI models to communicate with external tools. Instead of every AI company inventing its own tool calling system, everyone can just use the same MCP. Now here's the interesting part. Until now, MCP behaved much like a traditional client-server application. Every client first established a session with the server. Once connected, the server remembered information about that client, and every future request depended on that existing session. Look at this architecture diagram. Notice how every request continues through the same session. The server maintains state throughout the interaction. This design works perfectly fine for desktop applications or a small number of users. But as AI agents became more capable, developers started running into a serious problem. Imagine you have not just one AI assistant, but hundreds of AI agents working simultaneously. Some are writing code, some are searching documents, some are analyzing databases, others are scheduling meetings or calling dozens of APIs. Each one may perform hundreds or even thousands of tool calls every hour. Now imagine every one of those agents requires the server to permanently remember its session. Very quickly, managing those sessions becomes expensive, complicated, and difficult to scale. This is exactly the problem the new MCP update is trying to solve. The headline feature of this release is that MCP is now stateless at the protocol level, and this single change affects almost everything else in the specification. Now, stateless is one of those words developers use all the time, but let's understand what it actually means. Look at this comparison diagram. On the left, we have the old stateful architecture. The client connects once, a session is created. The server remembers that session, and every future request depends on it. Now look at the right side. Each request is completely independent. Every request carries everything the server needs to process it. Once the response is sent, the interaction is finished. No memory, no permanent session, no dependency on previous requests. At first, this may sound inefficient. Shouldn't remembering information make things faster? Actually, the opposite is true. Let's think about how websites work. When you visit a web page, your browser doesn't need to reconnect to the exact same physical server every single time. A load balancer can send each request to whichever server is currently available. That's one of the biggest reasons the modern internet scales so well. Stateless MCP brings exactly the same philosophy to AI tool communication. Look at this infrastructure diagram. Previously, if server number 3 owned your session, every future request had to return to that exact server. If that server became overloaded or crashed, the session was gone. Now compare that with the new architecture. Request 1 can go to server 4. Request 2 can go to server 1. Request 3 might be handled by server 3. The client doesn't care. The load balancer doesn't care, because every request already contains everything needed to complete the work. This makes horizontal scaling dramatically easier. Now, if MCP is becoming stateless, you've probably already guessed the next change. Sessions themselves are disappearing. Older versions of MCP relied heavily on session IDs. Servers had to remember which client belonged to which session. In the new update, that assumption is gone. Instead of relying on stored server-side memory, requests now carry the context needed for that interaction. This dramatically reduces infrastructure complexity. Another consequence of removing sessions is that the old initialization handshake also disappears. Previously, before the client could do anything useful, both sides had to exchange information. Protocol version, supported capabilities, features, compatibilities. Only after that could actual work begin. This worked, but it also meant every connection required an initialization phase. Now, this process has been redesigned. Instead of performing an initialization handshake every time, MCP introduces server discovery. Look at this flow diagram. Rather than opening a session first, a client simply asks, "What versions and capabilities do you support?" The server replies with its supported protocol versions, extensions, and capabilities. From that point onward, every request is self-contained. This approach is much simpler and fits naturally with the new stateless design. One of my favorite additions in this release is something called multi-round-trip requests, or MRTR. The name sounds complicated, but the idea is surprisingly elegant. Imagine asking an AI agent to book an international flight. The agent immediately realizes it needs more information: which airport, window or aisle seat, passport number, maybe even approval from your manager before purchasing the ticket. Previously, workflows like these naturally fit inside a persistent session. Now they can happen without one. Look at this sequence diagram. The client sends a request. The server replies saying it needs additional information. The client sends another request with that information. The server continues processing, then perhaps asks another question. Each interaction is still an independent request. Yet together they form a continuous workflow. That's exactly what multi-round-trip requests enable. It's one of those changes that's invisible to most users, but incredibly powerful for developers building complex AI agents. Another important improvement is header-based routing. Instead of relying on server-side session information to know where requests belong, routing information is now carried in request headers. If you've worked with HTTP before, this idea should feel very familiar. Think about sending a physical letter. The postal service doesn't remember your previous letters. Every envelope already contains the sender, recipient, and routing information. Each letter is completely independent. MCP is now embracing exactly the same design philosophy. Performance also received some attention. In earlier versions, clients often had to repeatedly fetch the same information from servers. For example, imagine asking, "What tools do you provide?" Most servers return exactly the same answer every single time. That becomes unnecessary work. The new specification allows many list-style responses, including tool lists, to be cacheable. Look at this comparison table. Instead of repeatedly downloading identical information, clients can simply reuse previously cached responses until they expire. That reduces latency, network traffic, server load, and even improves prompt caching in AI applications. Security has also been strengthened. Although the release isn't introducing an entirely new authentication model, it significantly improves how authorization fits into the protocol. This makes MCP much more suitable for enterprise deployments where permissions, identity management, and access control are absolutely critical. As AI agents begin accessing sensitive company data, these improvements become increasingly important. Another major architectural addition is the introduction of a formal extensions framework. This is actually a bigger deal than it sounds. Protocols become successful when they can evolve without constantly breaking compatibility. Instead of adding every future feature directly into the core specification, MCP now provides a standardized way to extend the protocol. That means entirely new capabilities can be added later without redesigning everything again. Features like tasks, enterprise-managed authorization, or future capabilities we haven't even imagined yet can all be built as extensions on top of the core protocol. This makes MCP much more future-proof. Speaking of tasks, this is another exciting concept introduced alongside the new architecture. Not every AI operation finishes in 2 seconds. Imagine ingesting an entire company knowledge base, generating a massive report, running code across thousands of repositories. These jobs could take minutes or even hours. Instead of forcing the client to wait with an open connection, MCP introduces tasks as a standardized way to represent long-running operations. The client can submit the work, receive a task identifier, and check its progress later. This is much closer to how large-scale distributed systems operate in the real world. Now it's important to mention that this isn't just a feature update. This release candidate includes breaking changes. Existing MCP implementations will need updates to support the new architecture. SDK maintainers, server developers, and client applications all have migration work ahead of them. That's exactly why the team published a release candidate before the final specification, to give the ecosystem enough time to adapt and provide feedback before everything becomes official. So, why does all of this matter? Because AI is changing. We're moving away from simple chatbots. The future belongs to AI agents. Agents that browse the web, write code, analyze documents, coordinate with other agents, interact with dozens of enterprise systems, and execute long-running workflows. That future simply demands infrastructure that scales like modern cloud software. The old session-based approach worked, but the new stateless architecture is built for the next generation of AI systems. If I had to summarize the entire release candidate in one sentence, it would be this. MCP is evolving from a protocol designed for conversations into a protocol designed for large-scale distributed AI systems, removing sessions, making every request self-contained, supporting multi-step workflows without persistent connections, adding extensibility, improving scalability, and preparing for enterprise deployments, all point toward the same goal: not making AI models smarter, but making the infrastructure around them dramatically more robust. And as AI agents continue becoming more capable, this invisible layer, the protocol connecting models to tools, may become just as important as the models themselves. That's all for today in Dots and Arrows. Thanks for watching. See you in the next.